Now that we know how much data we need to store, let's figure out how we can design our database to store it. So what all categories of data do we have? We have users data we need to store. Although YouTube doesn't specifically need you to create an account, but when a person does create one, we can store his login details, profile picture, and other meta details. Then for videos themselves, we can store their metadata like likes, views, comments, etc. And finally, we need to store the actual videos and their thumbnails. Let's deep dive into these three categories individually and see which database solution works best for them. For the user data, we can store a unique user ID against every signed up user, their name and email address. A lot more can be added, but this is fine for now. As we calculated in the last section, the total view users for next 5 years would be around 2.2 billion. Let's assume that around 30% of the viewers will sign up. If you feel that a different number makes more sense, like say 60%, that is also fine. You just need to communicate that to the interviewer. 30% of 2.2 billion would approximate to 660 million. 1 million is 10 to the power of 6. Let's take upper bound of 660 to approximate it to 1000. This approximation will help us simplify calculations. So 1000 million would now come out to be 10 to the power of 9. If we want our value to be of the power of 2, we can approximate 1024 to 2 to the power of 10. So 2 to the power of 10 to the power of 3 will be 2 to the power of 30. This is just a little less than 4 bytes. This means that we can assign all the 660 million users an ID of at most 4 bytes. Since the interviewer would have gotten a good idea about your thought process, you can approximate other fields roughly, like name could use 10 bytes and email could be stored in 20 bytes. So for 660 million users, we're looking at 660 multiplied by 34 bytes of storage of user data. To solve this, we can simplify 34 by 30 and 660 by 700. So 700 multiplied by 30 bytes would come out to be 21 GB. Storing 21 GB isn't really a challenge for most of the DBs, so we can simply use a MySQL DB to store these, which would also provide us ACID properties. Next, let's see how much storage we need for metadata of videos. We can store video ID, title, description, thumbnail, uploader ID, likes and dislikes corresponding to each video. For metadata of comments, we could store a unique comment ID, the comment itself, video ID, for which the comment is, commentator's ID, parent comment ID in case a comment is a reply to another, and the timestamp. So, as we assumed in last section, we need to handle 200 video uploads per second. So total videos every year would be 200 multiplied by 60 by 60 by 24. This approximates to about 15 million. With 3% annual growth for 5 years, we would need to store 17.4 million videos. So metadata for 17.4 million videos would be multiplied with total size per video. This approximates to 350 GB. Now, if an average one video gets 100 comments, 17.4 million videos will get 1.7 billion comments. So the total comment meta we need to store would be 1.7 billion multiplied by per comment size. This would approximate to 65 TBs. Now this is a lot of data, so perhaps we should think around a shared and horizontally scalable database. We also don't need strict consistency. If any of this metadata takes replication delay, it's going to be just fine. So perhaps a distributed and scalable DB like Cassandra serves our purpose. Now finally, let's see how do we store our videos. Since the size of videos are huge, they are usually stored in file storage system rather than data storage. Since we'll be storing a video in multiple streams, we could structure our storage in a way that all the chunks are stored in the same directory. To optimize retrieval, later on we'll deep dive into the partitioning scheme of this storage. Since we'll have a lot of videos, we need multiple distributed servers to store them on. We'll deep dive into this in the scaling section. Currently, there are multiple file storage solutions in the market which would help our use case like Hadoop file system and Amazon S3.